Okay, my name is Rafael Monnerat. I work for Nexedi, and today I will talk about collecting PyData from your running process. It's mostly about some experience that I have while in collecting data in SleepOS. But to begin, I will explain a bit what Nexedi does. It will contextualize why I arrived to the solution that I'm explaining. Nexedi is one of the largest open source software publishers in Europe, and it produces a lot of software. We produce more software than we produce logos, so there are more software than this. And we started with ERP5, and as the nature of the ERP5 was designed to handle mission-critical applications, we end up developing components and other solutions to handle additional kinds of mission-critical applications. Well, I pass too much. I don't know how to use a MacBook. So in SleepOS, we are a hyperconvergence OS. So we deploy services on a wide variety, various kinds of computers, which are located in data centers and or homes, or even in small Raspberry Pis. So each project, we end up with a different setup that is required to be done to handle a need of a certain project or company that we sell for. Then, with SleepOS, we currently have 3 masters which are deployed in VFib first, that is where we started, that we use not only internally but also externally, and we host our biggest projects. We do provisioning of services using VFib. There is a TerraLab, which is we do big data and KVM's deployment, and the TerraLab is used by the largest, so it's handled by the Min Telecom. We just support them. And it handles the largest, I think, and the biggest customers, one of the biggest customers in France for this kind of service. And the latest one is GrandNet, which is a CDN based in a mesh network that is deployed with SleepOS, that is able to provide the service for French companies inside China and Chinese companies in outside China world. So we can somehow optimize the problem of pass by the Great Firewall of China. So currently we have more than 100 computers in 11 countries, so we are quite distributed. And we have a wide range of different machines. I didn't count, but we had in 100 computers, we might have 20 or 30 different kinds of hardware or setup or VMs that we have to handle for our customers. And we unified all the monitor of all computers and all different projects and all different masters in a single monitoring that I will show more. And we can optimize the human resources to manage all this with only 2 persons working part-time to maintain. It's like 20% of the time of a person, and the rest of the time we use to improve the system. So, where does SleepOS collect data from? as we are in the wide range of different computers and VMs and Chromebooks and different devices, we establish a minimal set of what we should collect. So we collect the CPU, disk, network. Most of them are collected with PSUtils. So it's just a standard library in Python, with the exceptions of two things. One is for temperature that we don't collect in all computers. We don't use a PSUtil because it's not part of PSUtils, at least not yet. And for specific disk usage from users, we don't use PSUtils, neither Python solution, because as soon we start to measure performance, it was way too slow to use Python for collect compared to just to use disk usage of DU of Linux. So we wrapper this in our solution. So from SleepOS point of view, everything is collected periodically. You can, and it depends how much periodically you run this command. But how SleepOS gets the data from the process. So SleepOS is installed in a machine that is not always dedicated to SleepOS. So it can install in anyone's computer, or can be installed in a lab that is used by students while it's doing background processing of something, of big data or whatever. So we just get the process that are related to the SleepOS, and we build snapshots as soon we invoke the command or we call the API. So when we take when we collect, we put everything in a class to make it easier to take snapshot. We just pass the process to and we take a snapshot of all meaningful informations that we have. So it can be, so we use we collect not only CPU, but a number of threads and certain particularities that we can use later for machine learning or even invoicing. So not only the process, we also have to collect data from the computer itself, because if we wanted to measure if the computer is saturated or not, we have to compare what we collected from the process of the users with the total usage of the computer. So this is mostly how we do. So the entire API was written in a way that you can use is internally on SleepOS, or you can use it to take snapshots by importing it as a library. So I give you an example to take a snapshot of a computer. Then I give another example to give a snapshot of the current process, and this prevents you to re-implement all the collections again in your library, for example. In addition to that, we can also build reports out of it. And in this case, I'm building consumption reports, which is one of the biggest problems in cloud computing these days. There people are unable to make invoices. So by doing this XML, we can compile an invoice out of it by detecting how much each user uses from the system, from disk, CPU, and memory point of view. You can include even more. You can include disk I/O and and not network usage, at least not on this version, because it would require a certain machine-wide configurations that we try to avoid, to not customize so much the Linux distribution that we want to run. So why we collect this data? So what we use this data for after we take the snapshots and store it. Actually, in this slide I forgot to mention that we also have a simple way to store the snapshots. So we use mostly the snapshots and the all collected information for three things, which is monitor, the second is invoicing, and the third is for detect failures or create tickets if a submachine is using more resource than it should. Or for example, if the user is running out of core, using out of core PyData, but is skipping the out of core and going to memory and crashing somehow the machine. So we using so in SlapOS, as we do out of core PyData, we have to be sure that nobody is breaking the environment of the other person that is in the same computer. So once we monitor, we collect all the data, and we simply put the data out on HTTP. So we develop a built-in JavaScript application that can directly access the server and plot the data in JavaScript. So there is no need for a central place where you store the servers. Each server contains the data that you can directly access on it. So, and with one application only, we can monitor multiple clouds, and by using the IPv6 that we deploy with SlapOS, we can directly access machine in a person home and get the data to plot to know what's going on there. And we do not only this, we can know the status of everything that is in the cloud, and every user can know directly accessing their partitions, the data that is there in the state of their service, even if our masters are completely down. So we don't depend at any point of the master. And we can also see per user processing list directly from the browser. So the collected data taking the snapshot is directly shown in the browser. Then the next thing is, in addition to monitor, we have to invoice, because not all we have to invoice to, for example, to know how much a project is cost, or for example, in case of TerraLab, how much their customers consumed in resource to make invoices and to charge by the usage. So the report that was built by the SlapOS, it can be built by the SlapOS, or you can just use the same library. So the report is reported to one of the masters, depending who is controlling which computer, and based on this, we can generate invoices. For example, how much memory this user used in all his partitions, and how much CPU time he used, and how much disk he used, computing all the process that he has and any amount of computers that he handles. But we want also provide details. So in master, there is reports that you can generate to know how much each partition, which is a group of process in a kind of mini container, consumed in resources and CPU, memory, and disk usage on this case. So the problem of monitor is that you have everything distributed. We plot in the browsers, but one partition can produce a lot of information, 8,000 lines entry in a database, in a SQLite database, which means is a lot. And we only monitor once a minute because in a shorter than this, we will produce so much data that we won't be able to analyze. And it's okay because we don't care so much about CPU percent when we invoice, but we charge for CPU time. And so one computer with a lot of usage can produce 40 megabytes in CSV files, and 100 computers that we have today can produce about 6 gigabytes of data every day, which is stored in these computers. And the browser, of course, cannot handle this amount of data every day when you access it. And the browser also has it cannot cross-referencing information that are not owned by the user that is using the browser, for example. So to collect data, we use Wendelin. So we ship everything to Wendelin in order to produce tickets and do machine learning and use Python out of core PyData and to produce reports. And these reports are used for either for scientific approach or internally for to check the reliability of the machines. And to ingest data, we could just post the data, but it would be a bit reinvented what FluentD does. So we use FluentD to ingest data, but we didn't want to put FluentD on all 1,000 computer partitions that we have. So for this, we implement a crawlers, which is just a web crawler that we implement that can collect the data that is available on HTTP that is used by the monitor. So we just crawl the data that the user already see. So if the user wants a different kind of big data with the data that he uses, he could implement his own crawler or just do wget. So we implement crawlers that can grab data from all the computers that we have, independent from which customer or which master they are located on, and we put everything on Wendelin. So we combine a bit of a pull and push for not increase the amount of resources that a partition has to run up front. That's why we don't put FluentD everywhere and Ruby and so on. So we try to keep minimal for the user. So, and in Wendelin, we can produce, this is just a report. This is actually a Python notebook that I published recently. I didn't screenshot the part of the code, but there is code below. So this was written after the collected data of some network tests to prove that an IPv6 was faster than IPv4 in a worldwide point of view. So to conclude, so we can do Python-only data collection by using PSUtils and some of standard libraries. As a OS and a platform, for example, they are quite handy, or even multiprocessing, it's possible to do. And it's also useful not to collect only data for monitoring, but also to define thresholds for your application. Because sometimes you can load more memory that your computer has, so it's quite handy to just use PSUtils to collect the data. And we can do Python only out of core with Wendelin. Not only specific to Wendelin, the full solution, but with a Wendelin core. If you access the application if you access the presentation, in the bottom has some links to Wendelin core that can provide out-of-core NumPy arrays as a library in Python. So you don't have to literally use the full stack. So thank you very much. If anyone have questions about other kinds of collection of collect data, or how we do a specific kind of data collection that I didn't show, you feel free to ask too. Thank you.